Okay, so this is the Math at Work 10 lesson, measuring area or area measurements. Okay, so in this lesson we're basically just going to go over some review of how we calculate area of particular shapes, and we'll just kind of go through each of those in this particular lesson, then you'll have some practice worksheets to try as well. Okay, so let's get to it. Okay, so in this lesson we are going to focus on areas of squares, rectangles, triangles, and circles. Okay, so these are our basic shapes that we need to know. Some of this might be a review for you. If so, that's great. This should be a relatively easy lesson. If not, and it's somewhat new, then please kind of follow along and pay attention as we go through this. Okay, so what we've been looking at so far is we've been dealing with various values for both length in both imperial and metric units, and what we're going to be doing now is moving on into, instead of just length measurements, we're going to be moving on to area measurements. And again, those area measurements could come in either imperial or metric units, and again, all of our stuff with conversions might have to come into play depending on the scenario that we've been given. Okay, so because the big thing to keep in mind here is that like it says here, you must make sure all dimensions of the shape you're dealing with are in the same units before completing your area calculations. So the formulas we'll go over today only work if everything is in the exact same units, right? So if something's measured in feet and then another side length's measured in inches, you need to make sure that they're in both feet or both inches. Or if one value is measured in centimeters and another value is measured in inches, you'll need to convert to either both inches or both centimeters. Okay, so use all of our knowledge that we've done so far on conversions to work that out before you even start your area measurements. Okay, so again, our important units and notations as we go through this particular entire chapter, right? So again, we're going to be dealing with inches, feet, yards, and miles. These would be the important values, the units that are imperial, right? And in area, you'll notice here that all of our area values are squared, right? They have this exponent 2, right? So that's the area value. If it's an inch by inch, is going to be inches squared. If it's feet, if all the measurements are in feet, it's feet squared. Yard is yard squared. Mile is mile squared, right? This is really important that you actually do put the correct units here. We'll talk about that again. The other thing you might see is just something saying square inches or square feet, okay? It's the same thing. Right, so if someone said it's this many inches squared or this many square inches, it's talking about an area measurement in that case. Okay. In terms of your SI or your metric units, again, what you'd be dealing with is like millimeters squared or centimeters squared or meters squared or kilometers squared. These are going to be your most common ones that you're going to see throughout this work. Okay. So again, noticing how all of those important units were squared, right? They all had that little exponent 2 there, or they were called square whatever, square units, okay? This is extremely, extremely, extremely important in any area calculation, okay? So a unit with a squared value represents the area of a 2D, so a two-dimensional object, but without the squared value, it only represents a length, okay? There is a big difference from going to the store and saying, hi, I need to get paint that's just going to cover a length of just 3 meters across the floor, right? So just like a line of 3 meters versus saying I need enough paint that's going to cover 3 square meters, right? Where this is 3 meters squared, okay, being covered in here. So there's a big difference, and units absolutely matter, right? Not only do they matter, like we've already talked about before, in terms of what you're actually measuring, right? So like 3 inches is very different from 3 centimeters. You need to make sure you put your units on things. We also need to make sure it's the right exponent there, right? So in any area calculation we're doing, it's whatever the unit is squared, okay? All right, so when we define area refers to the interior measure, right? So what takes up the inside of a two-dimensional shape, okay? It refers to the number of square units needed to cover that the interior of that figure. So you might even think about like placing a piece of graph paper over top of it and counting the number of little squares it would take to cover in whatever shape you're dealing with, right? Like the number of those actual squares would help represent the area, right? Because it's square units, okay? The formula for area depends on the shape, okay? And the capital letter A is always going to be used to represent area for shorthand here. Okay, so again, what I'm saying here is that depending on the shape, if it's a rectangle, it has one formula. If it's a triangle, it's a different formula. If it's a circle, it's a different formula. Okay, they'll all be in a formula sheet, and we're going to go over all those formulas today now as well. Right, so this lesson is going to focus on basic area calculations of squares, rectangles, triangles, and circles, and that'll essentially be it. We'll look at more complex composite shapes in another lesson. Okay, but this is really just let's make sure we know which formulas to use when and how we apply those formulas. Okay, so we'll start with the area of a rectangle. Okay, when we talk about the area of a rectangle, it's simply calculated by taking the length and multiplying by the width, or you might see terminology that also says the base times the height. Either one works. Length times width has often been used like in elementary schools, right? As you get higher up in mathematics, we often tend to we prefer this base times height because it applies to other shapes as well, right? When we look at a triangle, if we talk about base times height, it relates better because there's better connections. Okay, so you will see both. Either is fine, but base times height is kind of the more higher mathematically correct one, I guess we could say. Okay, so let's just run through a quick example here. Okay, so we're going to be asked to find the area of a rectangle that has dimensions of 15 meters by 6 meters. Okay, so I've given you the diagram there. We can clearly see that this length here is 15 meters and this length here is 6 meters. Okay, so we'll switch to the whiteboard, go over those answers. Okay. So if we're going to do an area calculation here, right, since this is clearly a rectangle, our area calculation is going to come from area is equal to base times the height. The base represents the bottom length, right? And or if you were given the top length, right, if this was given as 15, you can infer that this is 15 as well, because if it's a rectangle, opposite sides are equal, okay? So what we're doing here is just taking 15 meters and we're multiplying it by the height. Right, going straight up is 6 meters, and when we multiply those two numbers together, 15 times 6, we get a value of 90, and again, don't forget your units, meters squared, right, because what happened was you did meters times meters, right, so there's 2 meters being multiplied, so that becomes meters squared, so your answer for that rectangle is just 90 meters squared. All right, let's keep going. Okay, so the answer is in there as well, so if you want to go back and look at it, it's good to go. Okay, now moving on just quickly to a square. Right, now a square is actually just a specific type of rectangle where all the lengths are the same. All right, so again, this is one of those things where all squares are rectangles, but not all rectangles are squares, right? Because if we define what a rectangle is, it has to have 4 sides, 4 interior right angles, and opposite sides have to be equal. And a square meets all those criteria. Their opposite sides are equal, they have 4 sides, and they have 4 right angles. But in order to be a square criteria, all of your sides have to be the same length. Okay, so the formula is pretty much the same, right? You'll see here that it's still the length times the width, or the base times the height, but since all of the sides are the same, you can really just call it side times side, right? Or when you have 2 things that are the same multiplied together, you can rewrite it as just something squared. Okay, so you're just seeing that area being represented as s squared, where s represents the side length of a square. Okay, so if we look at this example, it's just asking us now to find the area of a square with side lengths of 7 centimeters. Okay, so we'll do that one on the board as well. Okay, so again, what we've been given is a square, so these little lines here are just representing the fact that they're all equal, right? So that's 7 centimeters, that's 7 centimeters, that's 7 centimeters, and that's 7 centimeters, right? So the side length of the square is 7 centimeters. So we've been told we can use a formula where area is, you can either think of it as just still like base times height, where it would be 7 centimeters times 7 centimeters, right? Or you can think of it as the value of s squared, right? So area is equal to the side length squared, but you notice it's the exact same thing, right? 7 times 7 is going to be 49, 7 squared is 49, so whichever way you use this, you still get a value of 49, and again, your units are square centimeters or centimeters squared, okay? Right, because again, it was you were squaring the centimeters just like you were squaring the 7, or it was centimeters times centimeters giving you centimeters squared. Okay, moving on. All right, so again, you see that example, the answer come up there, so it'll be in your slides. All right, so moving on to a triangle now. Okay, so if you think about a triangle, basically, or you think about any 4-sided shape, right? Any four-sided shape, you could cut in half, right? Draw a line right through it, and you'll make a triangle, and you'll actually make two identical triangles, right? Or if you take any triangle and double it and kind of rearrange them in a particular order, right? Kind of flip one and sit it next to each other, you will get either a rectangle or a square, right? So because of that, the formula for the triangle is simply the formula for the rectangle, but cut in half. So our formula for the rectangle is base times height, which is this same part here, but then you're taking that value and you're dividing it by 2, or cutting it in half, right? So you'll either see the formula as base times height divided by 2, or you might see it a little bit more neatly presented where it's A is equal to 1/2 bracket B times H, right? So what that's representing is it's half of the base times the height, right? So dividing something by 2 or multiplying something by 1/2 gives you the same thing. Either of these formulas will always give you the correct answer, okay? Another thing to note, though, that's really important when it comes to triangles is that the height of a triangle, right, that H value here, is always perpendicular to the base, meaning it makes a right angle with the base of the triangle, okay? So you kind of got to look for where is that right angle in the triangle, and sometimes that's going to mean that the height is exactly one of the side lengths because it is a right angle triangle. Sometimes it might mean that the height would have to happen somewhere inside the triangle, right? You'd have to draw a line from the tip all the way straight down, and that'll happen inside and create your right angle, and that'll be your height. And sometimes you get a weird kind of slanted triangle where the height, if you drew a line from the tip all the way straight down, you actually are drawing a line outside the triangle, but that's still the line that you're using to calculate the height. So here's some diagrams to kind of show you what I mean by this, right? So this would be our first example, right? You see this little line or this square, this represents a right angle, right? So when I'm saying look for that perpendicular or that right angle, that's what you're looking for in the shape, right? So in this triangle, your base is here, right? It's just along the bottom, and your height is going straight up, right, where it meets the base at a right angle. Okay, so in this example, the height is actually one of the side lengths. This is a right angle triangle, right? In this example, you'll see the height is coming from a line that's actually inside the triangle, right? So again, this would be the base, right? Where the base and the height meet, you get a right angle triangle here, okay? And this value, right, from the very top all the way straight down to where it meets the base at a right angle, that would be the height, okay? This happens to be a nice little equilateral triangle, but this could just be, could be a little bit slanted, and this doesn't necessarily cut this into exactly 2 pieces, but either way, as long as you see that that's where it meets at that right angle, that's the height you can use for your triangle calculations. This is the example I was just talking about where you kind of have this weird slanted triangle going on, where again, here's the peak, right? This is your base here along the bottom, right? From this big letter B to this big letter C, they've labeled as just small letter A. Okay, that would be considered your base, and the height, right, is from the topmost part coming straight down. And you notice when you draw that line coming straight down, it's not actually inside the triangle at all, right? It's kind of outside it. So when you do this type of thing, this length here is the base, this length here is the height, even though that value is, it's not the same as this slanted length here, and it's not actually a value inside the triangle itself, but it's still what you need to use to calculate the height because it's the distance going straight up, right, and meeting that point, okay? All right, so we're gonna look at 3 examples, right, one of each of these kinds, right? So again, what you've got is that first triangle, right, and I'll redraw it and we'll do these together, right? So there, I'm just gonna redraw these questions here so that I have them and don't have to be flipping back and forth. Okay, so let's do those 3 examples. All right, so in that first one, in A, what you've got is one of these triangles here. And they show you that this length along the base is 6 centimeters. They do show you that that dotted line going from the base to the tip is the height, and they've labeled that as 9 centimeters. So to find the area of the triangle, it's the base times the height, and then you divide it by 2. Okay, so in this case, the base is going to be 6 centimeters. The height, right, where it meets at the right angle, that's going to be 9 centimeters. And then we'll divide that by 2. So your 6 centimeters times your 9 centimeters is your 54 centimeters squared. And then when you divide that by 2, that's when you're going to get your 27 centimeters squared. Okay, dividing it by 2 does not affect the units here, right? It's still centimeters squared. You're not dividing by another centimeter. It's just cutting it exactly in half. Okay, so our answer for A here would have been 27 centimeters squared. Okay, for B, you have a right angle triangle that looks like this, right? And you've been given that the value down here is 4 centimeters and this value here is 5 centimeters. Okay, so again, this is a triangle, so the area of our triangle is calculated by taking the base, multiplying it by the height, and dividing it by 2. So the base is 4 centimeters. The height, where it meets the base with the right angle, is 5 centimeters. And then we're dividing that by 2. All right, so your 4 centimeters times your 5 centimeters is going to give you 20 centimeters squared. And then you're cutting that in half, so your area is just going to be 10 centimeters squared for that second triangle. Okay. That third triangle in C is the one where the height is outside of the triangle. Okay, so for C, you get this triangle that kind of looks like this. Okay, and you've been given that this value here along the bottom is 9 inches, and then you kind of see this dotted line on the outside that tells you that that's 5 inches, and I realize my diagram is not to scale here, okay? If it helps people with their imaginations, I will try and do that to make it a little bit more to scale, okay? So again, you don't see the right angle inside the triangle, so you can't use that length, but where you do see the right angle is outside here, right? So this height, right, from the base going straight up, right? So if I kind of went straight up this way as well, right, and just figured out, well, what was that height? Okay, that ends up being 5 inches. So that's the value we're going to use for the height for our triangle calculations here for area. So again, our area is equal to base times height divided by 2. You'll often see brackets around that, meaning like do that first, do the base times height first, and then divide by 2 after. Okay, so here you're going to go 9 inches is your base, times your 5 inches as your height, and then divide by 2. Right? So 9 inches times 5 inches will give you 45 inches squared, divided by 2, cut 45 in half, and you get 22 and a half inches squared. Okay, and that would end up being your answer there. Okay, so those are the triangles that we did. All right, and again, you'll notice that the examples are also just typed out here for people who are just wanting to look at the notes and not the video. Okay, so last shape we're going to cover is just circles, okay? Now, obviously, there are no sides to a circle. We just have one smooth connected line, right? Now, we've already looked at circles. We've talked about what the diameter is, the distance going all the way across the circle. We've talked about the radius, right? Half of the diameter. And we've done this formula for the circumference, right, which is like the perimeter going around the circle, and needing to use the ratio of pi in order to accurately calculate that. And pi shows up again when we talk about the area of circles. Okay, so again, if you remember that the radius of the circle is denoted by the small letter r, and it's the distance from the center of the circle to the outer edge of the circle, right? Or you can consider it as half of the diameter. So the area for a circle is actually given as area equals pi r squared, and the multiplication symbols here are just implied, okay? They're just right next to each other, so that would imply that they're being multiplied, okay? So what that's actually saying is that you're taking the value pi, multiplying it by the radius squared, or if you think about what squared means, it means the same thing multiplied by itself, right? So that would mean radius twice, right? Radius times radius, or radius squared, and then multiplied by pi. And that'll give you your formula for area, okay? With this one, obviously because pi is an irrational number, meaning it's just going to keep going on and on and on and on forever with decimals, your question will typically ask you to round to the nearest something. Okay, you'll have to. in this scenario in order for it to work. Okay. You'll notice in one of the worksheets that I give you to work on for area of circle, the solutions that they give leave everything with just the radius squared, and I just leave it as a pi as part of the answer to give it as an exact value. I'm going to redo that solution set for you so you can see what it would be if you actually multiplied by pi, right? Because no one actually measures that way in any sort of real life measurements. Okay, they actually round to the nearest something. Okay, so let's just do a quick couple of examples here. So in this first one, we're going to have one with a radius of 6 centimeters, and in our second one we have a diameter of 18 inches. Okay, so let's do those. Okay, so in our first one, right, there was our circle. They showed the distance from the center to the side as a value of 6 centimeters, right? That is the radius by definition, the distance from the center to the outside of the circle. So the area formula is pi r squared, okay? Or you can think about it as pi times the radius, or just pi times radius squared. Okay, if you're going to think of it this way, don't forget to use your order of operations where exponents comes before multiplication. Okay, so your area is going to equal pi, right, that button they're going to use on your calculator, times the radius, which is 6 centimeters, squared. Right, so for squaring 6, that means 6 times 6, that's 36 centimeters squared. So the area would be pi times 36 centimeters squared, and then that's what we'll do, right? So 36 times the pi, and we get a value of 113.097, and it keeps going, right? So let's just round this to the nearest tenth, right? So 1 decimal place, and since the second digit here is a 9, this would bump up to a 1. So this should be 113.1, and then again, my units are in centimeters squared. And that would be the area of that first circle. Okay, now the next circle that was in that slide was one that we didn't have the radius, but instead we had the distance going all the way across the circle, right, as 18 inches, right? So you might remember when we did circumference, we kind of had 2 different formulas, right? You had circumference was either equal to pi times the diameter, or circumference is equal to 2 times pi times the radius, and you could kind of choose based on what you were given. With area, there is only one formula, okay? The formula is area is equal to pi times the radius squared. So when you've been given the diameter, you have no choice but to find the radius first. So remember that the relationship there is that the radius is exactly half of the diameter. Okay, so if the diameter here is 18 inches, cut it in half, and you get a value of 9 inches here. Okay, so the 9 is the value of the radius, so that'll go in there for your formula. Okay, so your area is equal to pi times your radius, which is 9 inches squared. All right, so again, the multiplication here is just implied. Okay, if you need to write it in, write it in. Okay, but that is a common practice for math, right? When you see just 2 things kind of just next to each other, it does imply that they're being multiplied, no other operations happening, right? So again, don't forget to apply your exponents before you do your multiplication. So do your 9 inches squared, so 9 squared, 9 times 9 is 81. So you get pi times 81 inches squared. Then you'll multiply that by pi. You get a value of 254.469. So let's say we were asked again to round that to the nearest tenth. So if I just write that out, it's 254.469. If I want the nearest tenth, right, so just 1 decimal, I have to look at the second number, right, the one directly behind it, and say, okay, well, what is that? That's a 6, which means that'll bump up to a 5. So 254.5 inches squared. Okay, and there's my second circle. All right, and again, you do see those answers there. Okay, so the last thing to just kind of touch on in this particular video is just talking about conversions with area. Okay, so sometimes, again, might be different units used in a shape. And you have to have the same units in order to do the area calculation formulas, right? So if it's in feet and then another length is in inches, you're going to need to put them all in one or the other. Sometimes you'll get a choice. Sometimes a question will specifically ask you to what is the area in feet, and then that would kind of force your hand in turning everything into feet first. Now, sometimes you're already given an area calculation. Maybe you don't actually have the original dimensions of the shape. They just say, oh, well, I did the measurements and I need, 38 square feet of carpet, right? And you get to the store and they say, well, we don't sell carpet by the square foot. We only sell it by the square meter. What do you need in terms of square meters, right? And you don't really know the original dimensions. All you were given was the square footage. So if you have to do that conversion just from meters, from feet to meters, you can still do that, but again, be very careful, right? We've already done the conversions with length of going from, inches to centimeters or feet to meters, but since this is area, right, and area involves two dimensions, that means if you're going to do the conversion, you actually have to do it twice, okay? And I'll show you the example of that now in a second, okay? It's because its length was just a one dimension, so you just had to multiply it by the conversion factor once. Area is a two dimension, right? It involved two dimensions of like a base and a height, right? It's the area on the inside, so that means you'd have to multiply by the conversion factor twice, right? And then if you were thinking of like volume, then you'd have to multiply by the conversion factor 3 times. Okay, so let's go with this one. So we're going to try and calculate the area of a rectangle with a base of 3 feet and a height of 7 inches. Okay, so it's just basic shape, length of base of 3 feet, height of 7 inches, and we want the calculations in both. Okay, so let's do that on the board. Now the answers are already there, but let's just kind of show how we would do it. Okay, so we've got a rectangle, okay, where the base was 3 feet and the height was 7 inches. So already we need to make a decision here because this is feet, this is inches. I can't just do my area calculation and go, oh, it's just 3 times 7. No. That doesn't work, okay, because the units are not the same. So I have a choice. I can either convert the 3 feet into inches or I can convert the 7 inches into feet, okay? Let's just go with going 3 feet into inches. So I'd start with my conversion. So I'll take my 3 feet and I'll multiply it by a conversion. I'm only converting a length here, so I only need to multiply by the conversion factor once, and the relationship between feet and inches is that there are 12 inches in 1 foot. And again, it's those same conventions we've been doing all class, right? So far, where it's been like, take what you have, multiply it by the conversion factor, what you want on the top, inches, what you have on the bottom, your feet will cancel, 3 times 12 is 36, okay? And then that's 36 inches. Okay, so what that means is that that 3 feet could be rewritten as 36 inches. Now that these are in the same units, I can do my area calculation, and area is equal to my base, which is 36 inches, times my height, which is 7 inches there, okay? And then 36 times 7 gives me 252 inches squared, okay? So there's my area in square inches. Now it's asking me to also give the value in square feet, okay? So you might think, again, this is the common mistake that everyone says, oh, well, I'll just convert this inches into feet, I'll divide it by 12, and I'm good to go, right? If you did that and you did 252 divided by 12, that's saying that 252 square inches is the same as 21 feet squared, okay? Now, let's see how that works out, right? If we wanted to put this actually in feet, right, this can go back to our 3 feet, and we'll have to convert our 7 inches into feet as well. Okay, so the 7 inches would have to get multiplied by the 1 foot per 12 inches, and that gives us a value of 0.5833 repeating. Feet, okay? Then I could do my area calculation as 3 feet times 0.583 feet. Okay, so I'm just going to leave that inches one still there. So the area would be the 3 feet multiplied by the 0.583 feet Now, if you kept all those decimal values left in your calculator, it's the 0.583333 repeating, and then multiplied by 3, you get a nice answer of just 1.75. Okay, if you only kept like 0.58, multiplied by 3, you get like 1.74. It's not off by a huge amount. Okay, so it's 1.75 feet squared. And you can see that clearly doesn't match that original thought of, oh, I would just divide this by 12 because there's 12 inches in a foot, because that gives us 21, definitely not 1.75 feet, right? So this is where that point is that I talked about, is that since it's an area, you have to multiply by the conversion factor twice. If I take that 252 inches squared and then I multiply it by my 1 foot per 12 inches, and then multiply it by my 1 foot per 12 inches again, right? 2 dimensions, inches squared, well, that's 2 inches. 2 inches there can cancel with 2 inches there, and I'm left with feet times feet, which is feet squared. And that means I'm taking my 252, dividing it by 12, and then dividing it by 12 again, and it gives me a value of 1.75 feet squared, which is the exact same as what it was up here. Okay, so if you're doing an area conversion just straight up, right, what you need to do is multiply by the conversion factor twice, right? Same with this. I could have taken that 1.75, multiplied it by the 12 inches per foot, but done it twice, and I would have gotten 252, the same thing. Okay, so just really something important to keep in mind as you go through. Okay. And again, I've shown that there. All right, so that's all that we're doing in this particular lesson. It's just getting our feet back under us for calculating area, because that's all what Chapter 3 is now, is all area calculations. Okay, so to start with, I'm just going to be giving you a few worksheets to practice your skills here, just basic worksheets on calculating area, triangle, areas of rectangles, triangles, and circles. Okay, and the answers are actually going to be posted for this as well. So I'm not asking you to hand these in. I just want you to do them for practice, and then you can check your work, right? Check your answers with the answer key to see, oh yeah, I'm doing this right, I'm okay. But if you're not getting them right and all your numbers are off, that's your cue to say, okay, I gotta, send an email to Ms. Keats, or I need to ask for a Google Meet session so that we can kind of figure out what it is I'm doing wrong and what I'm getting wrong values. Okay? So that's kind of where we're at with area measurements, and then in our next unit we'll be looking at more word problems with area. Okay, once we have the calculations down, we'll expand to word problems. Okay, and that's that lesson.